So for the final part of this section or this chapter, we're going to talk about hypothesis testing for population standard deviation. The other sections after this are just deciding which one to use. It's kind of clear usually because they'll talk about a proportion of people. They'll say this many people out of this many people have something. That's when you know it's a proportion. They'll say things like the mean is this. Let's determine whether the mean has changed, and that's kind of an indicator that it's a mean one where you're talking about a t-test or a z-test. And then finally, the last one is when they have a standard deviation. And in that case, you're going to use the chi-squared test um, to do this. And so, or I'm sorry, the chi-squared distribution to do this. And so we're going to go through how to do this through these slides. I also have another video that I go through the homework with you to help you understand what chi-squared is and how to use the calculator to do it. So let's hope that you guys are good to go on this. Oh, it's writing. Let's see. So, here we go. Oh, I didn't know I could write on this. That's crazy. It's letting me write now. It wasn't letting me do that before. So, for a chi-square distribution, we have this formula. This formula is very important. All it is n minus 1. That's the degrees of freedom times s squared over sigma squared. They're going to have to give you sigma squared. This is going to be your test value that you're testing for. That's going to be where your H naught is and your H1. This one they're going to give you, and then they're going to tell you how big the sample is, and so you'll be able to do this. Okay, so we keep going. Characteristics of a chi-square distribution. It is not symmetric, so I'll show you the shape of it, and it depends on the student t distribution, what the actual shape is, but it's all pretty similar to one another. As the degree of freedom changes, the chi-square distribution becomes more symmetric, and the values of chi-square are non-negative, so it's every value greater than 0. So you can use 0 as your lowest point in a chi-square distribution. Okay, so notice the purple one is more of like a normal curve, but all the other ones are sort of like this. They're high on one end and they get lower and lower. Okay, and as you add more degrees of freedom, it becomes more and more normal. Okay, that's what they want you to notice. Testing a hypothesis about the population variance or standard deviation. To test about these things, the sample is obtained using a simple random sampling method or from a randomized experiment. The population is normally distributed. So you need a normally distributed population to do this. We just assume they are. Once again, the only thing that's changed here, this is sigma. Okay, if we were talking about the mean, it's assumed to be the population standard deviation. The mean is the assumed value of it. So, okay. So select the level of significance alpha based on the seriousness of making a type 1 error. You compute this because we're going to use that in the calculator. You do have to do this every time, so just get used to doing it. It's really quick and easy once you've done it a couple times. We use n minus 1 degrees of freedom, but we don't use the table, so you don't have to worry about that. You got critical values that look something like this. If it's two-tailed, if it's left-tailed, if it's right-tailed, you know this is greater than a value. The one previously was less than a value, and then this is when it's not equal to. Okay, we use a calculator and we use the p-value, so we don't worry about that. You compute this test statistic, and this is for the p-value, and then you compare it to the alpha that you've chosen. That has not changed. If p falls in that range, then it works. Alpha obviously would be the chi naught squared. We have this one, and we use a statistical spreadsheet or calculator with a. We don't do that. If p is less than alpha, then we reject it. That's why I like this approach the best. We don't have to worry about which side of p it's on or which side of the test statistic it's on. We just worry about if p is less than alpha or not. So these procedures are not robust. Therefore, if analysis of the data indicates that there is a variable that does not come from the population that is normally distributed, the procedures presented in this section are not valid. Okay. So to do this, you could, a can of 7-Up states that the contents are 355 milliliters, and quality control engineer is worried about filling machine being miscalibrated. In other words, she wants to make sure that the machine is not under or overfilling the can. She randomly selects 9 cans of 7-Up and gets the following contents. In the section 9.2, we assume that the population standard deviation was 3.2. Claim the test or test the claim that it's greater than 3.2 milliliters more than it should per can. Okay, so we would go and we'd set up all of this. Obviously, what she wants to do is she wants to calibrate it so that it doesn't put too much soda into each can or too little into each can to get the company sued. The test statistics 9.374 with 8 degrees of freedom, that's 15 point something. So because because the chi-squared that for her calculation is 15.507, and it's hard to do this with that. Okay, let's look at the p-value. I can do this one. That is, the p-value is greater than 0.10, which is the alpha that they had chosen. Then since p is greater than the level of significance, we fail to reject the null hypothesis. So all that means is the probability was bigger than 0.10, so then we can't reject it. And so there is insufficient evidence at the level of 0.05, to conclude that the standard deviation of the can of content of 7-Up is greater than 3.2 milliliters. Okay, with that being said, watch the next video and I'll show you how to do it with the calculator. It's pretty straightforward. It's not the most difficult thing to do. I kind of went through this one quickly because I know I give you better examples. If you want to use data, you just have to enter them into the list and then choose data instead of statistics, and then the calculator will take care of the standard deviation and things like that on its own. Thank you guys for watching. Hope you're doing well. Don't forget to watch the next video to see how to do all these things by calculator.